Hey, Michael Church, Crawl Space Ninja here with Todd Jackson again, and today we got another great topic we're going to talk about. We're going to talk about what are some of the biggest mistakes that foundation repair and basement waterproofers make when addressing bowing walls. Stay tuned. Okay, so if you're new to Crawl Space Ninja, we talk about everything related to attics, basements, crawl space, and ductwork. So make sure you subscribe to our channel and ring that notifications bell. Well, Todd, we're glad to have you back again.
Thank you, sir.
Thought we had a great talk the last time about what causes bowing basement walls, and we're going to put a link to that video down below. But today, we see contractors that maybe aren't as well versed in addressing bowing basement walls, and I wanted you to share your thoughts with everybody on what are some of the big mistakes contractors make when trying to address bowing walls.
One of the biggest problems is the diagnosis between settlement and lateral load, and whether that's going to be the foundation repair contractors, salesmen, or even sometimes structural engineers, because one looks like the other.
Okay.
When we've got a foundation that drops or settles, now it's cracked up and the lateral load takes over. So many times we're going to be looking at this wall that's cracked up and bowed, and we're going to attack the cracks without attacking the problem. In other words, the crack in the foundation is not necessarily the problem, it's a symptom. So we have to know what caused the problem in order to do away with the actual problem. Then we can deal with the cracks, which is going to be usually a secondary symptom of what's actually happening. So once a foundation drops, now you've got two problems. You've got settlement and you've got a lateral load. So typically what you try to train the contractors is to try to map out what's going on. Do we have cracks in the slabs? Do we have cracks in drywall? Do we have doors opening and closing? So we try to map out exactly what's the cause, because the crack is just telling you something happened to cause the crack.
Okay.
Normally.
Now, please tell us, what is lateral load? Go ahead and tell us a little bit.
Lateral load is going to be your compression load of the soil and the fluid pressure on the foundation itself.
From the outside in?
From the outside
Okay.
in. You've got a compression load that equals a push that equals a pull.
Okay.
In tension. And of course, settlement is going to be, and we're not talking about natural settlement where you've got various things. We're talking about soil issues where you don't have the strength to hold up the foundation. I'll give you a good example. On some of the old basements, you have the old cast iron, lines that go out to the street, coming from the actual toilets and,
Right.
and everything.
Right.
Okay. Over about 20 or 30 years, those cast irons, they start to dissolve. And what occurs is now that leaks into the soil, and it creates a substance that won't hold up the foundation. So you'll go in there, and generally where you've got your clean out going to the street, you'll see certain amount of settlement because of contaminated soil.
Okay, so the soil around the cast iron gets softer.
Yes.
Basically,
yes,
and creates
it
settlement.
just about turns into a mulch.
Okay, so that's one of the issues of the settlement problems. You're not talking about the stair step crack from those
Well,
kind of stuff.
those are going to be a symptom of what actually dropped it.
Right. So which should, if I'm a homeowner and I've got a basement and I start to notice some cracks, what's acceptable, and then what should be alarming to me? If I've got a CMU or a cinder block that's cracked down the center, is that alarming to me, or is that normal?
Yes, depending on the thickness. If you've got a 12-inch, and typically your 12-inch would be a brick home, because a 12-inch is going to resist the lateral load much more, or a bending, if you will, than the 8-inch. You'll see that more on a 12-inch. In other words, a standard cracking pattern on a 12-inch with a brick ledge and a brick is going to be right at that brick ledge.
Okay.
Straight across, usually, simply because that's your bending moment, because you're going from a 12-inch to an 8-inch.
Right.
That's the weak part of the wall. Where on a 8-inch CMU, you'll see it about halfway down, all the way across in a mortar joint, and then you're going to stair step typically to the corners, It doesn't necessarily mean you have settlement in the corners. What it means is the adjacent walls are trying to hold it.
Okay.
So what we want to look for when we see those stair-stepping cracks, do we have cracks in the slab? Do we have matching cracks to that tells us something else is going on?
Okay, I got you. Now, if I'm looking to support that lateral load to keep it from pushing in and creating a bowing wall problem, is something like the Fortress stabilization system good for that? The carbon fiber that you all manufacture, and what makes that carbon fiber strap different from the competition?
Very good question. The carbon fiber is very, very good in tension. It immediately takes the load from the moment back to the top and back to the bottom, and more so than a steel I-beam where you're basically hitting it in one spot. You're taking the load all the way along. It's much like you'd have grout and steel in the wall.
Right.
The main difference of the Fortress carbon fiber is that we're the only carbon fiber that has ICC approval. That took about 3.5 years. We have to do testing of every lot. We've got where ICC comes in several times a year, takes it off the shelf. That's the International Code Council. And we did that because in residential it got to a point where you could buy carbon fiber on eBay and slap it up. And we wanted to do that. During that, we were testing for various anchoring systems, and very, very important for carbon fiber systems to be anchored.
Right. Okay.
And there's a couple reasons.
Top and bottom.
Top and bottom.
Okay.
And the main reason is that it's going to stop any tipping and it's going to stop any shear.
Gotcha.
But also, what's interesting is if I give you the strength or the data sheet on standard surface mounted carbon fiber, ACI, which is the American Concrete Institute, knocks that strength down by between 60 and 70%.
Okay.
Because of your long-term creep, so on and so forth, on surface mounted. So typically, if a design engineer, mostly on commercial, they're going to take that safety factor out of that. You anchor the carbon on both ends, you get 100% loading of the strength of the carbon.
From top to bottom.
That's correct.
Okay, and you'd mentioned that steel may not do that because if your wall's bowing in, steel, the anchor is where it's touching.
Correct.
Is that right?
Yes.
So it's not an even distribution.
Well, the interesting thing, and I did this seminar last week, you could specify in a 4-inch steel I-beam or a 6-inch steel I-beam. Which one is stronger? Well, it's all going to depend on how you anchor it.
Okay, so you mentioned two things real fast. You mentioned tipping and shearing. All right, real quick, what's tipping, what's shearing, so they understand what you're talking about.
Tipping and shearing is going to be not in the center of the wall where you're taking the load, but to the top and to the bottom.
Okay, so tipping's the top, shearing's the bottom.
Shearing's kind of interesting, and with a shear, it's very, very interesting in that you get a bending. You'll get a bending moment. Typically, you won't see a wall 4, 5, 6 inches out of plumb,
Right.
out of tolerance. It doesn't want to be. So what's interesting, and I'd like to call it the rubber band effect, as that wall starts to bend and bend in 3, 4 inches, what occurs is you get a compounding load of the soil. So most of your load is right here at the bottom as your compounding load.
Okay.
And you'll reach a point on the bending moment where all of a sudden, boom, the wall straightens itself. And that's shear. You'll see a lot of shears where you had your 2 to 3 inch in the center. That's gone now. It's straight. It's all slid off of
Because
the bottom course.
the bottom shear. So it's the pressure is stronger the deeper it
That's
goes.
correct,
Is
because
that correct?
you have compounding load.
Okay, so if you've got a 12-foot tall basement wall and it's all covered with soil, that shearing is more likely.
Absolutely.
Because of the hydrostatic pressure and the pressure of
And
the
because
soil.
you're held at the top and the bottom, what occurs is that it reaches a point where the wall, it straightens itself.
And the bow goes away,
Right.
but you just lost floor space.
Yeah.
Right.
Well, yeah, you don't want a 2.5, 3 inch shear.
Right, okay,
That's
okay.
correct.
Very good. So, again, this is about mistakes contractors make and all that. Me as a homeowner, how do I know, or what can I do to make sure that I protect myself from that engineer or that salesperson that's making a mistake? Is there some questions I can ask or anything? Is there any kind of testing that they are doing or meters that they should have out that I'm checking to make sure they're doing these things?
That's interesting. A lot of the homeowners do a lot of research now. You're going to get some and some bad, based on what you're doing. But a lot of them are pretty intelligent in what they're doing. Because of the internet now, you can look at, settlement versus lateral loading. So
Right.
a lot of the homeowners are pretty savvy on that. A lot of contractors will have their laser levels and various things of that nature, and plumb bobs and things of that nature. The most difficult thing is as-built condition. You can have a wall that's built 1.5 inches out,
Right.
and you just don't know it at that point in time.
True. Very true.
So what's interesting is concrete and masonry have an elongation of 0. In other words, they don't bend. So if I'm looking at a series of 1-inch cracks, that's telling me that wall's moved 1 inch from as built.
Right.
And I measure the cracking now as opposed to laser levels and so on and so forth, because I don't know how it was built. I'll give you a quick example. We had a project years ago, and they went in and pushed the wall back. It was out to 2.5 inches, and then they put the top anchors on it and the straps. And then we got a call about a year later, you got to come and see this. The wall had where the top straps were stayed, and the wall came in 2 inches. And I'm like, okay. I asked the contractor, do you have any before pictures? And this is very, very important for all contractors and for homeowners, before and after pictures. They showed it to me, and the original foundation wall had no cracks. So what occurred was the salesman went in, did their plumb bob, did all of their due diligence, and realized that that wall was 2.5 inches out. Well, Mr. and Mrs. Homeowner, we're going to excavate, push it back 2.5 inches, then we're going to strap it and keep it there. It was built that way. So what happened is, after they backfilled, the strap is trying to keep the one block with the carving, and the rest of the wall is moving back to as built.
I got you.
Interesting.
So the builder built it 2.5
That's-
inches
it
on.
must have been built on a Monday or Friday.
All right. Very good. Well, we appreciate you, Todd, coming and hanging out with us here in Knoxville, Tennessee. And my name's Michael Church with Todd Jackson, and I hope you make it a happy and blessed day, and we'll see you later.